Welcome to the very first session of Dr. Emag Sim channel. This channel aims to utilize simulation tool to explain electromagnetic phenomena. It is purely for sharing and educational purpose. What's your first reaction upon hearing electromagnetic wave? These are the feedback we could easily hear, such as radiation, hazardous, abstract, invisible, wireless, mysterious, intangible, and etc. In this channel, Dr. Emag will discuss anything about electromagnetic wave, ranging from basic principles, up to some design analysis. The conventional way in learning electromagnetic wave through textbook involves a lot of formulas, equations, and symbols, but Dr. Emag provides another dimension to comprehend this topic in interesting and fun ways. Dr. Emag hopes that this technique will grow everyone's interest in this topic. Anyway, are you aware that electromagnetic wave is currently one on the hottest topic? It is forecasted to bring tons of job and business opportunities for many years to come. In fact, electromagnetic wave exists everywhere in our modern life. It is something very common until without us realize it. He is one of our greatest scientists, who summarized these four equations, namely Maxwell's equation. To Dr. Emag, these formulas are absolutely wonderful as it beautifully characterize the electromagnetic waves phenomena completely. However, looking at the formulas and theories, probably many students will look like this. In fact, Dr. Emag was also like this 20+ years ago. However, after mastering 3D electromagnetic simulation skill, the perception has completely changed. Our intention here is not to focus much on the theory part, yet still able to provide a clearer picture on electromagnetic theory, its working principle, as well as understanding some common terms used in modern advanced technology. This is the appetizer for our future content, where you could expect a lot of animation videos, to enhance visualization on electromagnetic wave nicely. By the way, before we begin our adventurous journey, are you able to name a few technologies which is related to electromagnetic wave? When Dr. Emag reveal these names, you would probably be shocked to know that these technologies work based on electromagnetic fundamental. We have Wi-Fi, GPS, 5G, the newest communication standard, which operate in wireless mode. USB and HDMI connectivities, meanwhile are operating in wired or guided media mode. Dr. Emag will highlight more about this at later stage. Electromagnetic wave exists due to combination of time-varying electric field, or we call them E field, and magnetic field, or we call them H field. Both of them are orthogonal, or perpendicular, to each other. On top of that, both E field and H field are also perpendicular to propagation direction as well. Therefore, it is also called transverse wave. In this plot, you can imagine E field's amplitude will swing along x-axis, up and down with respect to time, H field will swing along y-axis, in and out with respect to time, while it is propagating in z direction, onto the right. As the signal contains time-varying magnitude and direction information, it is also called as vector field. Depending on the application, it is normally sufficient to just analyze either E field or H field in your component designs. Let's look at a scenario, where we can easily imagine and observe in daily life. Imagine when there is an object falling into water, the observations below can be drawn. Water splashing out from the surface. Wave is generated and it is propagating outward. At location near to spot where object fall, the fluctuation is high, while the wave gradually getting weaker at further distance. Well, we can literally see similar scenario in electromagnetic wave. As mentioned earlier, Dr. Emag will heavily rely on simulation results for simpler explanation. This E-field animation plot represents a physical visualization on wave propagation towards the right. If you remember correctly, the phenomena is rather similar to the example we shown in last page. Simulation tool has clearly shown us additional dimension to visualize electromagnetic wave, even though it is intangible in nature. For those who are still new to this animation plot, let Dr. Emag explain the physical meaning here. E field is generated, then moving, or propagating to the right. Red color represents strongest amplitude, while blue color indicates the weakest amplitude. Let's characterize a few observations in this particular animation plot. We call this region as near field, simply because they are near to source. The fluctuation in this region is rather high. As a result, it's not easy to get a consistent E-field strength if measurement is taken in this region. This region is located at far end, hence it's called far field region. Normally, the measurement taken in this area as it is already stable or reaching equilibrium stage. In electromagnetic field world, the word far means electrical distance, quantified by wavelength, or lambda. It is the distance between two consecutive peaks. Frequency is referring to the rate or time taken from one peak to another. Speed, frequency, and lambda are interrelated to each other by this simple formula. Electromagnetic waves brings energy into a system by virtue of their E field and H fields. Let me quote some daily life application which benefits from this nature, such as microwave oven, which cook our food, medical equipment like thermal ablation, which is used to kill cancer cell, energy harvesting to charge up batteries or power up equipment, and etc. Electromagnetic waves are widely used in communication world too. The main purpose is to carry signal from transmitter to receiver. There is another fact we could observe from this animation plot. It's quite obvious that E-field amplitude decrease over distance. Despite that, signal amplitude could decrease due to some losses in the medium as well. As a conclusion, it is rightfully to claim that signal decay rate is higher in a lossy medium. By nature, radio waves are non-ionizing, and easily transmitted through the air. It's ranging from few kilohertz up to 300 gigahertz, corresponding to wavelength of few kilometers to 1 millimeter. Radio waves are normally not hazardous at adequate power, thus make them ideal for communications purpose. Various type of communication standards had been developed over decades. It varies in terms of data rate, bandwidth, operating frequency, latency, and etc. However, bear in mind that we do not have absolute freedom to design device to operate at random frequency. It's simply because some of the radio spectrum is strictly used for military and security purposes. For instance, C-band synthetic aperture radar is used to obtain radar images on terrain and geological area, or some radio band had been strictly reserved for local authority, particularly for emergency communication purpose. Operating several communication standards at same frequency range may cause interference, potentially causing crosstalk, and thus affecting signal quality. The pictures here shown some application at its designated radio frequency band. Depending on the usage, RFID can be designed for short and long distance communication. It is designated to operate around kilohertz up to about 1 gigahertz. Since few decades ago, data transmission for radio channels and TV channels allow us enjoy broadcasting benefits, such as listening to radio at home and while driving. From communication point of view, we have gone through first generation to fifth generation, or 5G, which is in current deployment stage. By the way, researches on 6G is already ongoing, expected to deploy in 2030. Wireless communication research and development will continue to grow, but sadly to know that engineering design challenges have increased exponentially at the same time. To overcome the challenges, a good understanding on electromagnetic theory, and utilization on electromagnetic simulation tool are necessary and essential. Benefits of using electromagnetic simulation tool is not only limited to wireless transmission, it can also be widely used in guided media or wired transmission, such as transmission in printed circuit board, connector, RF cables, integrated circuit package, and etc. Dr. Emag will provide some examples to discuss about those design challenges in next videos. Besides that, Dr. Emag will also share with everyone regarding the technique to analyze results effectively through simulation tool. This is an E-field transmission in air medium. Obviously, this plot looks exactly the same as what we have seen in previous slide. Now, let's make some changes on the propagation medium, by adding a glass medium at the center. Next, electromagnetic field will propagate from air medium, entering glass medium the exiting to air medium again. A few observations can be observed here. E-field speed will be slower in air medium. Wavelength will be shorter in glass medium. As soon as E-field leaving to air medium again, the speed is back to the speed before it enters glass medium. Amplitude fluctuation in glass medium is quite severe. If we change all the transmission medium to only glass, why amplitude fluctuation somehow does not exist? Why? The answer is, when electromagnetic wave propagates from a medium to another, mismatch and reflection occurs. Amplitude fluctuation happens due to the superposition effect between transmitted and reflected signal. We can conclude that reflection happens whenever there are change of medium due to discontinuities or mismatch. As a result, it leads to deterioration in signal quality. By minimizing the discontinuities effect, signal quality will improve. A common technique to minimizing discontinuities effect is called impedance matching, which Dr. Emag will discuss about it in next videos. In last slide, electromagnetic transmission is going through air medium or free space, thus we could call them wireless propagation. Now, let's look at another type of propagation through transmission line. Perhaps this could be your first impression when I mention transmission line. That's true, but this is mainly for high electrical power transmission. However, we are now interested in transmission line for data, targeted at circuit, or board level. As soon as a complete electrical loop is formed, current will start to flow. Let's call the thick line on the top as signal net, while the thick line at bottom is ground plane. Let's transform this to something more practical, where actual transmission line on printed circuit board can be visualized as follow. Normally, signal net is pretty thin line, while ground appears in the form of plane. Both signal net and ground plane are built from metal materials, separated by a layer of material called substrate. This type of transmission line is called microstrip line. Signal net width, thickness, substrate material properties, and thickness will determine the line impedance of the transmission line. We will have more discussion about transmission line in a moment. Let's try to connect a signal source at location at one of the red cone, and a matched load at the other far end. Since a full loop is already formed, we can expect current to start flowing. This is a snapshot of surface current plot. Dr. Emag would like to show everyone that current direction on signal net and ground plane are 180 degrees out of phase, meaning to say, current has to flow from source to load, then return to source again in reverse direction. In actual electronic designs, you can visualize the signal source to be your integrated circuit, or IC. It is responsible to excite signals, then the signals will travel through the transmission line, subsequently reaching your load or destination in the end. The load could be your drum, memory devices, and so on. Of course, it is always our interest to receive perfect signal at load, preferably without any losses or deterioration on signal quality. In fact, this is one of the huge research topic electromagnetic field, namely electronic design automation or EDA. Technologies such as HDMI, USB, Lightning, and Type-C connectors are the recent data transmission standards you might be familiar, which is related to EDA industry. Due to the space constraint, compactness, and complexity of modern electronic designs, we normally do not have luxury to design such a perfect ground plane. It's quite common to see some gap in ground plane, but unfortunately current flow will become incomplete under such circumstances. The question now is, will current still flow in this case? Well, the answer is yes. You could visualize the gap as a capacitor. A capacitor behaves as open at DC, but behaves as short at high frequency. It is still able to form a close loop at non-DC condition, but it will somehow create fringing fields at gap area. These fringing fields may potentially cause leakage, and trigger structure resonance, eventually lead to potential interference or unintended radiation problems. This is also another big research topic in electromagnetic field. We call it as electromagnetic compatibility or EMC. Turn to the back of your electronic devices. You may see the wording such as FCC, CE, CCC, and etc. These are the governance body which regulates these interference issues. All these topics will be discussed in details in next videos. Electromagnetic waves travel with certain pattern. It is called propagation mode. It is as simple as visualizing how people travel from one location to another. People have the option to walk, run, jump, or crawl. We call that as mode. Dr. EMAG have listed out some commonly transmission lines in PCB boards, namely strip line, microstrip line, coplanar waveguide, and lastly, coplanar waveguide with ground. Let's visualize the 2D propagation modes together. The animation plot with arrows represent vector plot, while the contour plots are represented by colorful plots. It is easy to conclude that fundamental propagation mode in all these transmission lines look rather different from each other. Under normal circumstances, we always aim to have substrates with minimal loss. However, by nature, substrates tend to be more lossy with the increase in operating frequency. This has posed a huge concern for us, as our current 5G millimeter wave technology is operating at frequency centered around 27 GHz, a few times higher than previous generation. Therefore, another alternative type of transmission line, namely waveguide technology, is widely used 5G millimeter wave designs. As mentioned, waveguides are a structure that guides waves, but with very minimal loss, and also capable of carrying high power. Waveguide structure are mainly built of metal, but hollow at the center. Waveguide structure comes in various shapes, but Dr. EMAG will only show two types of commonly used waveguide, namely circular waveguide and rectangular waveguide. Similarly, electromagnetic wave travels in waveguide with some propagation modes. Please note that each mode can only travel in certain frequency range. From this vector animation plot, it's relatively easy to know that propagation modes in these waveguides are rather different. Signal transmission in printed circuit board and waveguides are called guided medium. Dr. EMAG had already mentioned that signal transmission is also possible through the air medium. The question now is, how could we ensure an efficient signal transmission? The answer is through wireless communication. Base station tower on the left will serve as a host to connect every clients in these environment, which includes buildings, cars, offices, factories, and etc. Out of this, I would say the major enabler of wireless communication is antenna. Antennas had been around us since ages, but it's worthwhile to highlight some commonly seen antennas here. Antennas come with various shapes and characteristics, but the ultimate goal is still to achieve seamless communication. These are the two commonly found antenna types, namely aperture type and wire type. When energy is excited into structure, electromagnetic waves are generated, subsequently transmitted through the air. Dr. EMAG will discuss more about antenna simulation in next videos. We are now coming to the last part of this video, which is about polarization. Nevertheless, we have already mentioned a few times that electromagnetic field is a vector field. Let's look at this circular horn antenna. This antenna is fed with circular waveguide, followed by tapered angle. Dr. EMAG has excited this antenna with two fundamental modes at source, as shown in our previous slide. Instead of looking at circular waveguide mode at excitation area, we would like to focus on the 2D E field at far distance, away from this antenna. If we were to look at center location of the 2D plot, we could easily conclude that vector field is rather similar to excitation modes. Here, the direction of the vector field is called polarization. E-field animation plot on the left is called vertical polarization, while E-field animation plot on the right is called horizontal polarization. In every efficient transmission, transmitted and received signals should always have same polarization. However, signal may be reflected on building walls, concrete, glass, metal structures, and etc. The signal will deteriorate due to polarization problem. Both vertical and horizontal polarizations are called linear polarization. Besides linear polarizations, Dr. EMAG would like to show another type of polarization, left-hand circular polarization and right-hand circular polarization. We call it circular, simply because the vector field is somehow circulating. You may be wondering that this circular polarization vector field is actually generated by the same circular horn antenna. It is as simple as combining both vertical and polarization fields together, but with the phase difference of 90 degrees. From reception point of view, circular polarization is definitely much more flexible as compared to linear polarization, simply because it has coverage in all directions. GPS antenna is one of the typical example which possess this characteristic, as it needs to provide seamless signal coverage to moving objects in random orientation. We are finally at the end of this video. In next video, Dr. Emag will introduce some fundamental parameters in electromagnetic theory. Hope you will like it. Please remember to like and subscribe to Dr. Emag Sim channel for more updates. Dr. Emag is always committed to produce more interesting videos to everyone. Thank you and see you again in next videos.